Today's topic is implicit differentiation. If you'll notice, I have a beautiful ellipse drawn on the board. All of the notes for today's lesson will be on a PDF on Classroom where you can see a really, truly beautiful ellipse drawn on graph paper that did indeed come from my hand. I know it's hard to believe, but it's true. Okay, so I've pre-drawn, this ellipse, 25x squared plus 4y squared equals 100. And I want you to find the slope of the ellipse at 1, negative 5 root 3 over 2. Okay, well this is kind of a loaded question because first of all, this isn't even a function. And if you look at just the point where x is 1, just where x is 1, there are two tangent lines. X is 1, it could be up here. That's where x is 1, and there's your tangent line. X is 1, and then negative 5 root 3 over 2, I don't know, here somewhere. Also a tangent line. So if you're not a function, you fail the vertical line test, which means you have two different potential tangent lines on the curve. So specifically for this one, I gave you the y value of negative 5 root 3 over 2. So implicit, this is an implicit function made up of two explicit functions. What on earth does that mean? Okay, that's half of an ellipse. It's a function. If all you have is this top half of the ellipse, it's a function. Then there's also, so this is, I'm going to say here, hold on, function here. And then there's also the function down here. Put them together, it's not a function. But the tangent line at the point 1, negative 5 root 3 over 2 does exist. Okay, so to save some time, if I wanted to plug this into my calculator, I'd have to solve for y first. I know if you have a fancy, like a TI Nspire or whatever it is, you can plug in x's and y's, but in all the other calculators that most of us have, the 884s, you have to solve for y in order to get this graph to show up. So I already did that to save us some time. When you solve for y, you get plus or minus the square root of 100 minus 25x squared all over 2. And on the notes that I'll post, you probably can't see them, but I have all the steps worked out for you. Okay, so two functions. There's the positive function, the upper half of the ellipse, and then there's the negative function, the lower half of the ellipse. If I want to find the slope, I need to find the derivative. So I'm going to use y equals negative root 100 minus 25x squared all over 2. And I'm going to find the derivative, and I'm going to use a combination of the chain rule and power rule. Yeah, chain rule, power rule. Okay, so dy dx, factor out the negative 1/2 of, and I'm going to write this as 100 minus 25x squared to the half. You can factor out the negative 1/2. It's the constant rule of differentiation, I think. I'm not sure exactly what it's called, but the negative 1/2 is a constant, so I factored it out. And now I'm going to find the derivative from here. So saving ourselves some time, actually, you know what? I'll show it. This becomes negative 1/2 times chain rule, power rule, 1/2 in front, decrease the exponent by 1, times the derivative of what's inside, which is negative 50x. Okay, and something tells me that the green might be hard to see, sorry. It looks all pretty on my board, but I have a feeling you can't see it. Okay, so all simplified down, this becomes 25x over 2 root 100 minus 25x squared. Yeah, I recommend that you stop the video, do the work, and then come back and see if you got the same thing. Okay, so I want to know the slope of the tangent line at 1, negative 5 root 3 over 2. This negative 5 root 3 over 2 doesn't matter once we started the process, so here's what I mean by that. Remember when I started and I said, oh, there are 2 tangent lines at 1. There's one at the point 1 comma positive something in the first quadrant and 1 comma negative something in the fourth quadrant. You needed to know that it's negative 5 root 3 over 2 in order to choose, did you want to use the positive version of the ellipse equation or the negative version? And then once, so this negative right here allowed us to choose, boom, and then we differentiated the whole thing, and now I'm going to plug in x as 1. If I would have said positive 5 root 3 over 2, we would have differentiated using the positive ellipse equation, the upper half, and done the whole thing. But I gave you the negative, so we're sticking with the negative. Okay, you do all the work and you get 25 over 10 root 3. Okay. I know I didn't rationalize. It's shocking. It's probably one of the only times I haven't rationalized ever. Okay, so we're going to hold that thought. You get 25 over 10 root 3. This is a royal pain in the butt. I had to solve for y, and I did it for you. Solve for y. Which equation do you want to use? Then plug in x is 1, whatever. Okay, that's not going to be conducive, a good method for 9 times out of 10. So what do you do instead? Okay, I'm going to erase all of this. So we have what's called implicit differentiation. And all the differentiating that we've been doing so far have been derivatives of y with respect to x. Or there was, man, I think it was in homework last week. It was, I'm so sorry. I don't know why these markers give me such a hard time. There was like dy, du, and then du, dx. I feel like I was just doing this yesterday. Maybe I was. So you're doing, oh, chain rule. That's what I was doing, sorry. So you can take the derivative of y with respect to u, the derivative of u with respect to x. All in all, that gives you the derivative of y with respect to x. Okay. So implicit differentiation says, well, I can differentiate y with respect to x if I put a little something extra on. So if I want to find the derivative of y with respect to x of the function 25x squared plus 4y squared equals 100, I'm going to do what they call taking the derivative of both sides. Okay, great. This was the very, very, very original function before we started. And I told you, I believe the point was 1, negative 5. I think that was the point, negative 5 root 3 over 2, perfect. Okay. The derivative of y with respect to x of 25x squared is simply 50x. Yeah? Okay. The derivative of 4y squared with respect to x, where's the x? So we're going to use the power rule. Then, I don't know what x is. If I don't get this cap of the marker off, I'm going to be finally. What's x's relationship in 4y squared? I don't know. So, for whatever variable x there is, I need to differentiate with respect to that. So the derivative of 4y squared in terms of x is the power rule, 8y, and then the derivative of y with respect to x. That sounds so confusing, I'm sure it is, but there's no x, you can't just differentiate with respect to x if there's no x there. That's voodoo math, not allowed. Excuse me. Then the derivative of a constant is 0. So if I can solve, remember the derivative represents the slope. The derivative represents the slope. Y changes on, oh, you know what? Let me redraw this. I just had this great thought. This was whatever it was. I don't know. 1. This was 1. What's y? Y changes. There's 2 y's for a non-function, in this case the ellipse. There are 2 y's for the 1 x. Well, which x am I referring to? I don't know. So the change in y depends on what x is. We'll look at it more closely. Hopefully that's at least a start to get you going. All right, then I need to solve for the slope. So if I solve, this is going to be subtract 50x, divide by 8y, subtract 50x, divide by 8y, and of course reduce that. And that's going to be negative 25x over 2y. Negative 25x over 2y. Okay. There's my x. There's my y. So the derivative, the slope of the tangent line at the point 1, negative 5 root 3 over 2 should be 25 over 10 root 3. And I'm pretty sure it is. So this is going to be negative 25 over 2y, which is negative 5 root 3 over 2. Bam. And this is indeed 25 over 10 root 3. This is supposed to be a 4. Whew. I was like, wait a minute, it doesn't work. It has to work. This is a 4. This is a 2. And now you do indeed get the same answer. So the slope of the tangent line at the point 1, negative 5 root 3 over 2 is 25 over 10 root 3. Okay, so we're going to look at a lot more of these. Okay. Okay, those of you who care to follow along in the book, this is number 4. And you are asked to find the derivative with respect to x. So if there's any letter in there besides x, you have to be careful. And generally it's going to be a y. If there are any variables in any of the terms that aren't x's, we have to be careful and throw in that derivative of y with respect to x. Okay, so x squared. Okay, so you're asked to differentiate y with respect to x. Okay, so in other words, that means we're solving for dy dx. So I'm going to differentiate both sides. Okay, the derivative with respect to x is 2x. Okay, here we go. I'm going to go slow. I'm not sure you can see the different colors, which is too bad. If we were at school, I'd be using all kinds of different colors. I'm going to use the quotient rule. So I was talking to Mr. McGurk, and I said, you know, should we use the product rule, the quotient rule? Which one do you guys use more in BC? And his response was, stick with the format of the problem. So if it's given to you as a fraction, use the quotient rule. Okay, so that's what I'm going to stick with. So the denominator, excuse me, the denominator, x plus y, times the derivative of the numerator, minus the numerator times the derivative of the denominator. This is going to be a long one, so I am going to do some skipping of steps for the simplification. There's just not enough room on the board. Over the denominator squared. Okay, here we go. The derivative of x minus y. Okay, so the derivative of x is 1. Minus the derivative of y is 1, but I'm differentiating with respect to x. So the derivative of y is dy dx. Minus x minus y. The derivative of x with respect to x, the derivative of x with respect to x is 1. The derivative of y with respect to x is the derivative of y with respect to x. Try and say that 10 times fast. I know some of you right now are trying to say it 10 times fast. The derivative of y with respect to x, the derivative of y with respect to x, the derivative of y with respect to x. You know what? You can mute me. Isn't that fantastic? Okay, now it becomes a bunch of algebra. So let me just go back and review this. The derivative of x with respect to x is 1. Boom, boom. The derivative of y with respect to x is the derivative of y with respect to x. All right. The derivative of x squared with respect to x is 2x. Now this becomes a bunch of distributing and combining like terms and yada, yada, yada. So this becomes, I'm going to do one more step and then I'm going to, and you can look at it on the PDF. X minus x y dx plus y minus y dy dx minus x dy dx plus y dy dx all over. Wow. Finally a problem that takes up the whole board. Over x plus y quantities squared. Okay, so I'm out of room. Essentially what you're trying to do now is solve for dy dx. So I need to erase this so you can pause it or do whatever you need to do. Once you get to this point, it's all algebra. Okay, so you end up doing some work and you end up getting down to x. X plus y squared equals y minus x. Y minus x dy dx. Okay, and then you end up with, excuse me, y over x minus x plus y squared equals. Yeah, okay. It's all in the PDF, all worked out for you. So if you have questions, just let me know. But what we really need to practice is the whole differentiating y with respect to x when there's no x there. So let's look at some more of those. Okay. Here we go. This will be number 8. Again, find the derivative of y with respect to x. So not only are you doing what we call implicit differentiation, now you've got to do it with a trig function, so that's always fun. X, y, great. Okay, so I want to find dy dx. Okay, so the derivative of x with respect to x is 1. Awesome. The derivative of sine is cosine times so the derivative of sine x is cosine x dx. So this is cosine y dy dx. The derivative of sine is cosine. So let's say that you have the sine of 3x. This is 3 times the sine of 3x. The derivative of, no, cosine. U is 3x, and then the derivative of u is 3. So the derivative of sine is cosine, and then the derivative of y is dy dx. Here you need to look at xy as the product rule. So x times the derivative of y, which is dy dx, plus y times the derivative of x, which is 1. So again, I did the product rule here. X times the derivative of y with respect to x is dy dx, plus product rule, y times the derivative of x with respect to x is 1. Okay, so let's subtract y. Okay. Do all the algebra and you get 1 minus y over x minus cosine y. Okay, 2 more. Okay, this is number 12. And let me write down the problem first. X plus 2 squared plus y plus 3 squared equals 25. It's a circle. Center is at -2, 3, and the radius is 5. So for this particular problem, they want to find the slope of the curve at the indicated point. So the indicated point is 1, -7. When x is 1, there are 2 tangent lines. When x is 1, it's a circle, there are 2 tangent lines. I want to know the tangent line at this point. That's what they're asking you. Okay, so we're going to do the power rule with the chain rule, and we're going to implicitly differentiate. It's a lot for one problem. All right, here we go. So we are going to take the derivative of both sides. Okay. The derivative of the constant is 0. It's always nice when you can say, see ya. One less problem to deal with. Here we go. 2. X plus 2, power rule. 2 comes in front, decrease it by 1, times the derivative of what's inside. The derivative of what's inside is 1. The derivative of x is 1, the derivative of 2 is 0. Move on. Okay, plus 2, y plus 3 to the first. The 2 comes in front, and then by the chain rule, take the derivative of what's inside. So what do you think is going to be the derivative of y plus 3 with respect to x? Derivative of y with respect to x. That's what it is, dy dx. Okay. Again, I'm skipping steps. Push pause on the video, do the work. You end up with negative x minus 2 over y plus 3. This is going to tell you the slope of the tangent at any point on the circle. Notice I haven't used the 1, -7 at all. I haven't used 1, -7. So if I wanted to know the slope of the curve at the point whatever, you'd find some x value, find the y value that's associated with it, plug in, and you would get the slope. This is the slope for all the lines on the curve at any given point. Now, for this problem specifically, I want to know the slope at 1, -7. Okay, so at 1, -7, that would be -3 over -4, which is 3/4. But there are an infinite number of points on this circle. So if I wanted to know, okay, when x is 0, I'm just going to make this up. Let's hope I can do it off the top of my head. So 0. When x is 0, that's 420. Oh, you know what? Forget it. On my calculator, I'm just going to try and like plug in points off the top of my head. It's not going to work. But hopefully you understand that specifically 1, -7. Anywhere on the circle, here's where I would plug in to find the slope at that specific point. Okay, I said 2 more. Now we're down to the last one. Did you know that like we're almost down to our last lecture? And I think there's only like 4 or 5 left. I think. Okay. Number 16 wants to know, where is the slope defined? Where is it defined? Okay, number 16. Slope. Everything about the slope is about the derivative. When you see slope in calculus, you should be thinking, okay, derivative. Which derivative do they want? Always start with the derivative. So, I'm going to find dy dx of x squared plus 4xy plus 4y squared minus 3x plus 6. Okay. This is where you're likely going to forget a dy dx product rule. So here we go. The derivative of x squared is 2x. There's a y. Automatically, it's messed up. So I'm going to use the product rule. I'm going to look at 4x as one term, and I'm going to look at y as the other. So here we go. Product rule, 4x times the derivative of y, which is dy dx, plus y times the derivative of 4x, which is 4y. 4x times the derivative of y in terms of x, it's dy dx, plus y times the derivative of 4x, which is 4. So 4y plus 8y dy dx minus 3 equals 0. Whenever there's a y involved in a term, there's going to be a dy dx on there somehow. Whenever there is a y involved in a term, there's going to be a dy dx. Well, Ms. Babak, there's no dy dx here. That's because this is a result of the 4xy derivative. Okay. Do some work. dy dx of 4x plus 8y equals 3 minus 2x minus 4y. All right, so the derivative of this, it's not a function, of this equation. The derivative of this equation, it's not a function. It's 3 minus 2x minus 4y all over 4x plus 8y. Okay, this is the slope. That's the slope. Derivative slope. Okay, so the question is, I didn't give you a specific point in the last problem with the circle. It's like 1, -7 or something. And we found the overall derivative, and then we found the slope at a specific point on the circle. I'm not giving you a specific point on this curve. I'm just wanting to know where is the slope defined? Slope. What do you think we need to look at? Yep. The denominator. If the denominator is 0, then this equation is undefined, and the equation represents slope. So, the denominator is 0. Bad stuff. Where is the denominator 0? The denominator is 0 where y equals -1/2 x. The slope is defined everywhere except, so it is undefined here. Vertical. Undefined. Slope is undefined. It's a vertical. All right, you guys. That is section 4.2. Post your questions on the stream. And if you're going to come to office hours, that's great. Make sure you come with questions prepared, though, okay? See you later.